So solving system of equations graphically. This is chapter 3, section 1, and this is what it's going to cover. So to solve system of equations graphically, you have a system of equations, two or more equations with the same variables. To solve a system of equations with two variables, you find the order pair that satisfies all of the system of equations. So what you guys are used to doing, or at least don't know if you guys remember or not, is last year we did substitution. And we also did elimination. Those are great ways of checking to see what solution you get, as well as now we're going to go over graphing. Now, what is the solution when you graph an equation? The lines intersect at a singular point. That point of intersection is the solution of the equation. You guys remember how to do substitution? You can go ahead and check if your graph is correct by solving by substitution. If you remember how to do elimination, you can check if your graph is correct by doing elimination. Now, how do you graph? Remember, we want to put it into first slope-intercept form. That is y equals mx plus b. And then after, you can graph by the y-intercept and with the slope. So if we wanted to do the 2x minus y equals to -1 into slope-intercept form, I would start by subtracting the 2x on both sides. And that's going to give me -y equals -2x minus 1. Then I'll divide by -1, and I'll get y is equal to 2x plus 1. So that is how you would graph that. It makes it easier. Another way you can graph is by solving. So that's one way of graphing. Another way you can graph is by finding the intercepts, like you did for your last test. Grab those intercepts and then just draw a line between them. So if I were to want to find the intercepts of that first equation again, let's say I want to find the x-intercept, you do, well, 2x minus 0 equals -1. 2x equals -1. X is equal to -1/2. And if you notice, x crosses right at -1/2 for that line. And if we look for the y-intercept, we will plug in the 0. So 2 times 0 minus y equals -1. This is -y equals to -1. This is y is equal to 1. And if you notice right there, it intersects at 1. So there's multiple ways that you can graph it. Now you have 3 different types of equations when you're solving by graphing. So the relationship between the graphs and solutions of a system is shown below. You have the one solution, which is where they intersect at one point. You have infinitely many solutions, or also known as all real numbers. You can also write all real numbers if you prefer. Where is you draw the same line twice. And then you have a set of parallel lines, which means it's a no solution. How do you know if a line is parallel? Parallel lines have the exact same slope with different y-intercepts. So I'm going to say it again. Parallel lines have the exact same slope but different y-intercepts. So please keep that in mind. I'm not asking you to solve for it. I'm just saying if you see 2 lines that have the same slope and different y-intercepts, it's no solution. If you have the same slope and the same y-intercept, it's all real numbers. And they're completely different equations, you will get an answer because they will intersect at some point. So you have 3 different types of solution. One solution, all real numbers, which is infinitely many solutions. Or no solution, which means the lines never touch. So they want us to solve the system of equations. Now, of course, we're doing it by graphing because this is what this section is going to be. So I'm going to rearrange this one. I'm going to do it in black. So it's going to be 3x plus 2y equals to -2. So when I rearrange it, I'm going to start by subtracting the 3x. Again, I'm just rearranging it into slope-intercept form. And then after I subtract it, the 3x, I will divide by 2. And I get y is equal to -3 over 2x. minus 1. Now, if I were to do that, I'm going to do the other one in red. I'm going to get negative 4x plus 5y is equal to negative 28. So you would start by adding the 4x, and you get 5y equals to 4x minus 28. We'll divide by 5, and we get y is equal to 4 over 5x minus 28 over 5. Now, if you get a fraction, you're more than welcome to do the x and y intercept. So we get a fraction for the y-intercept. Now, this is going to be 5 point something, so as long as I put it between the 5 and the 6, it should be fine. What you guys can also do is solve for the intercepts. So, for example, if I want to solve for the y-intercept, for that red one, I'm going to do negative 4 times 0 plus 5y equals, sorry, not the y-intercept, the x-intercept. If I wanted to solve for the x-intercept, it would be negative 4x plus 5 times 0 equals negative 28. That's going to give me negative 4x is equal to negative 28. And that's going to give me x is equal to positive 7. Now, why did I find the x-intercept and not the y-intercept? The y-intercept is already here given to us when we have it in slope-intercept form. Now, when it comes to graphing, if you prefer to have a whole number, you can always find the intercept to figure it out. So, I'm going to go ahead and draw the graph to the best of my abilities. So, just kind of bear with me. So we're going to start the line that I did in black. We're going to start at the negative 1. We're going to go down 3 and 2 to the right. Down 3 and 2 to the right. So it's kind of going to look like this. Again, this is not perfect. And the line that we did in red, instead of putting the point of negative 28 over 5, which is going to be 5 point something, I'm going to put the point of 7 for the x-intercept, which is right here. And then we have a slope of 4 over 5. So I can go up 4 and 5 to the right. Or I can go down 4 and 5 to the left. So when I do that, it's 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So the line's going to look kind of like this. Now, after you graph them, you have, this is your solution right here. This point right here. That point is 2, negative 4. That is your solution. Your answer is that order pair of 2, negative 4. Alright, so for 1A, you can either start by finding the slope-intercept or the intervals. I'm going to try the slope-intercept first. So we subtract the 2x from both sides. So we get negative 5y equals negative 2x plus 11. I'll divide everything by negative 5, and we get y is equal to 2 over 5x minus 11 over 5. And when I rewrite the second equation, I'm going to do it right here. Negative 3x plus 4y equals negative 13. I'll start by adding the 3x on both sides. And we're left with 4y equals to 3x minus 13. I'll divide by 4, and we get y is equal to 3 over 4x minus 13 over 4. Now, both of these are fractions, and even if you were to have gotten the intercepts, it would still be fractions for everything. So we're just going to do our best to graph this. So the first one's going to be, I'm just going to do, again, just bear with me. Okay, so we're just going to do the first one. So negative 11 over 5 is going to be negative 2 point something. So I'm just going to go ahead and plot it right there. We go up 2 and 5 to the right. So we're going to get a line that's going to look kind of like this. And then for the other one, we're going to start negative 13 over 4, which is negative 3 point something. We're going to go up 3 and 4 to the right. So the line is going to look something like this. Now this point clearly is not at an exact line. So we're going to say that is negative 1.5. Sorry, negative 1.5. That's going to be positive 3 and negative 1.5 for the y. Again, this is just an estimate of where that point is going to land because this one's not perfect. Alright, so I'm rewriting 1b just to make sure I have space. So 1b is 4x plus 3y equals to negative 17. And then the other equation is negative 7x minus 2y is equal to 20. Now, I'm going to I wrote them separate just to be able to solve them right off the bat. So I'm going to go ahead and start with minus 4x. So I'll get 3y is equal to negative 4x minus 17. Then I'll divide by 3 and we get y is equal to negative 4 over 3x minus 17 over 3. Now I'm going to go ahead and do the same thing on the second equation by starting by adding 7x on both sides. So I get negative 2y is equal to 7x plus 20. And then I divide by negative 2 and we get y is equal to negative 7 over 2x minus 10. So I'm going to go ahead and try and graph this. Again, just kind of bear with me. So I'm going to graph this one first. Negative 17 over 3. It's going to be negative 6 point something. So I'm going to put it right there. Then we're going to go up 4 and 3 to the left. So 1, 2, 3, 4. 1, 2, 3. So the line should look something like that. Now I'm going to graph the second equation. I'm going to start at negative 10. Right here, and we're going to go up 7. We're going to go left 2, so right there. So it's going to look kind of like this. Again, it's not perfect. It won't be perfect unless you have a grid. In my case, I don't have a grid. So we can see that they're going to meet at, I'm going to say negative 1, negative 4. Because they meet right there. That would be the solution. Again, when you draw this on a grid, it will make it a lot easier. So guys, I'm going to do 2a and 2b by solving for the intercepts. So I'm going to write the equations here. So if I want to solve for the x-intercept, I will plug in 0 for the y. So we get 4x is equal to 12. When I divide by 4, we're going to get x is equal to 3. And if I'm solving for the y-intercept, I will plug in 0 for x. And then I get 3y is equal to 12. I divide by 3. And we get is 4. So when we draw that line, we have a positive 3 for the x and a positive 4 for the y. You can just draw the line in between like that. And then we're going to find the x and y intercept of the second equation. So for the x-intercept, again, negative 6x plus 0 equals negative 1. Negative 6x equals negative 1. X equals 1 over 6. So again, 1 over 6 is not 1, but it's also not 0. So I'm going to put it like right there, as close as I can. Again, it's not perfect. And then for the y-intercept, it would be 0 plus 4y is equal to negative 1. When I divide by 4, I get y is equal to negative 1 over 4. Again, something like that. So it's going to look kind of like that. Like the graph should look kind of like that. Again, when I have a grid, it makes it easier. Right now, I don't. So the point of intersection is right there. I am going to say that is 0.2, 1 for the solution. So I'm going to write 2b here. Again, just to make sure I have space. So I'm going to do negative 3y plus 8x equals to 36. And then the other equation was 6x plus y is equal to negative 21. Now for the first equation, again, I'm just going to solve it for x and y intercepts just to show you a different way. So for the x-intercept, this becomes 0 plus 8x equals 36. Now we get 8x equals to 36. We divide by 8. Now 36 over 8 doesn't simplify exactly into a whole number, so we're just going to simplify by 2. So divide the top by 2, divide the bottom by 2. So that's going to be 18 over 4. I can divide by 2 again one more time. And we get 9 over 2. So my x-intercept is 9 over 2. That is 4.5 if you prefer mixed numbers. Now I'm going to erase the simplifying, so I have space to do the y-intercept. And then for the y-intercept, it's going to be negative 3y plus 0 equals 36. So this one will become negative 3y is equal to 36. When I divide by negative 3, I get y is equal to negative 12. Then I'm going to get the x and y intercepts for the second equation. So for the x-intercept, it will become 6x plus 0 equals negative 21. So it's 6x equals to negative 21. Divided by 6, we get x is equal to negative 21 over 6. Or for people who like mixed numbers, it's going to be negative 3 over 6, which simplifies to negative 3, 1 over 2. If you prefer mixed numbers. Now for the y-intercept, it will become 0 plus y equals to negative 21. So y equals negative 21. When I go to graph this, again, bear with me. Okay, so I'm going to graph the x-intercept of 4.5. And I'm going to graph the y-intercept of negative 12. Again, it's going to look kind of like that. Not a great drawn line. And then for the other one, we have a y-intercept of negative 21. And x-intercept was negative 3.5. So right there. When we draw that graph, again, this is hand-drawn, so it's not perfect, but this will be the solution. I'm going to say that it's negative 1, negative 13, just to kind of estimate where the solution will be. Again, this is an estimate because it's not perfectly drawn. But again, the solution is right where those lines cross. You guys have homework on Canvas, but this is it for today's notes.